All right, CNT125, Chapter 12. We just kind of got done talking traffic monitoring, baseline, that sort of thing. So now we're looking at bandwidth management. There's a couple different things that can be done for bandwidth management: flow control, congestion control, or quality of service. The flow control is usually the kind of thing that's occurring between two nodes, two devices, computer server, computer kind of thing. And it's these kind of things that get done to minimize the amount of data sent, so it does not overwhelm the receiver, if you will. And these are the kind of things we mentioned back when we talked TCP three-way handshake, TCP sliding window kind of deal. So just to kind of put that in perspective for you. So the stop and go, you literally send a frame, you wait for acknowledge it, send a frame, wait for acknowledge it. That's a lot of overhead. Usually not too efficient. A lot of times you'll send a handful of frames or a handful of bytes and then wait for an acknowledgement to come back, or we send a handful of frames and then wait for acknowledgement, and I can pick up a missing piece by acknowledging using a very specific acknowledgement number used. These are ways that you can control bandwidth where I'm not overwhelming an entity. Another way that can be done is through congestion control. Here you can actually configure links where we don't have, we have forward congestion, reverse congestion to make sure that we're not overwhelming a link, if you will. Congestion control, we have before it occurs, open loop congestion, or remedy closed loop after it starts, after the congestion actually starts. So there's different things that can be done: retransmission policies, window policies, acknowledgement policies, discard policy, etc. These are different things that can be done to, again, minimize the amount of stuff that's going across a link to an entity. Closed loop, you can start doing implicit signaling, explicit signaling, letting know that, hey, the network's congested, do something different. That sort of thing. Choke packet can, a router experiencing congestion, create and send a choke packet to the traffic indicating, hey, there's congestion, reduces rate of transmission. Those kind of things can get done to let devices know, or other devices know, that there is congestion on a link. Another thing that can be done is your quality of service. Your quality of service, I think that was the last one that was mentioned up here. Let me go back up here real quickly. Let me keep going. Yeah, flow control, congestion control, quality of service. Good. I just want to make sure I was on the right track there. Well, quality of service, we know that there's things like video transmissions that are delay sensitive. Meanwhile, regular data, a little bit of loss can be, or a little bit of delay can be acceptable. So the voice and video is delay sensitive, but and even voice and video is a little bit loss tolerant, and data is hey, I need to make sure it's all there, but it can be delayed a little bit, not a big deal. So with that in mind, you can do some quality service on the type of traffic moving across a link. So voice and video is delay sensitive, loss tolerant, so I can make sure that those maybe get priority over regular data traffic. That is the quality of service type thing that can get done. So we can do traffic shaping, manipulating packets, data stream connectors to the minor traffic, traversing a network interface, and again, assuring timely delivery, optimizing performance for all users in a portion of the network. Some traffic shaping techniques: delay less important traffic, which is called buffering. Okay, that can actually be done. You can hold on to the less important traffic and let the priority traffic through, and then send it on its way. Increase priority of more important traffic. So again, I can make voice and video jump to the head of the line, or I can get a whole bunch of voice and video through, then some data. A whole bunch of voice and video through, then some data. I can limit traffic volume flowing in and out of interface during a specific time period. Maybe during a specific time period, I'm just, YouTube streaming, if you will, during work hours kind of thing, that kind of thing. Limit monetary throughput rate for an interface, and again, this is also traffic policing. Now, there was a period of time Comcast was doing this kind of thing on traffic to areas, because at the time, the Comcast network was kind of like a bus topology, where it was kind of like a whole neighborhood was sharing the bandwidth. So you would have a neighbor using I'll just say streaming services, maybe in those days it was like BitTorrent, that sort of thing, downloading things, using a lot of bandwidth, and that was stealing the bandwidth away from the neighbors. And the neighbors would complain. So what Comcast did at one point was they were doing what was called deep packet inspection. They were looking for those BitTorrents and that sort of thing, and dropping some of those packets periodically, and freeing up some bandwidth for the neighbors. Well, it didn't take long till nerds like us figured out that was going on and said, hey, Comcast, what are you doing? So that was a big controversy at one point in time. But that's an example of traffic policing. Yeah, here's traffic volume before and after applying limits and that sort of thing. Yeah. So traffic prioritization, again, we can base that on particular protocols, particular IP addresses, diff-serve flag field, if you will, in your IP header. A specific VLAN, maybe a voice VLAN, gets priority. A certain application gets priority. So this can actually be set up where I'm doing priority of certain types of traffic over other types of traffic. And some of you might have already encountered this. You connect to like Wi-Fi, like a library or something, and you're doing just regular browsing data. It's fine. You try to stream something while you're working, and that might getting very choppy. And what most likely they're doing is saying, hey, you're just doing browsing, research here, fine. That's regular traffic. All this other stuff is taking bandwidth from other people, so we put that low priority, and your stuff might be getting buffered or that sort of thing. So like, hey, that's taking bandwidth away from other people. That would be an example of like quality of service. Two different ways this can be done, using the diff-serve field or the class of service, if you will. The diff-serve field, if you remember in your IP header, there is a diff-serve field, and that can get used to allow a certain type of traffic through or given priority. And here's just kind of example of things that can get done. I can match certain packets from this field of my IP header and allow that traffic through first. On IP version 6 packets, there's the traffic class field. Same type of idea. That traffic class could get priority over something else. And then there's two types of forwarding from this: expedient forwarding and assured forwarding, to make sure that this traffic gets priority over something else. And here I show you in different, like telephony, your diff-serve field, if you will, right here. Your IP phone could be expedient forwarding, and the multimedia conferencing could be assured forwarding. And again, that could be set up in an access list to give this traffic a priority or a better priority over a different type of traffic. Class of service, again, similar in nature. This is more layer 2 now. With your class of service, I might indicate a certain VLAN gets priority over another VLAN. So as I look here, this is your tag that would be looked at, and you can have your class of service. Your priority code point would be read there to know if this VLAN traffic or this class of traffic gets priority over something else. And again, here's some config that can be done to do this class of service processing of data moving through. All right. When we come back in the next, we'll start talking, response and recovery and incident response and so forth.